So what I want to talk about in this lesson, we're just moving on to Geometry 1, and this is Chapter 11 in the textbook. So we're going to be looking at, so it's called Geometry 1. And when we look at this, we just need to kind of cover a little bit of revision on angles and triangles. So let's have a look at that. So if we take this here, so this here is an angle, and we have the angle is formed here, and the angle here is a 90-degree angle, 90 degrees, and it's known as a right angle. So right angle. And another way to think about it as well is you can look at it as what's called a quarter turn. And this quarter turn business, where it comes from, it kind of comes from this. So imagine if you had, let's say, you start here, and if you do one rotation in this way, it's a quarter turn. So this is a quarter of the whole thing. If you turn 2 quarters, it'll go like this, 3 quarters like so, and then 4 quarters like so. So each of these sections here are a quarter. So again, this is it's just revision. So this is what's known as a right angle. On a complete turn then, let's say, so each section here is 90 degrees, 90, 90, 90, and 90, and then a whole turn or a complete turn would be 360 degrees. So imagine if you're standing here and you're looking in this direction, you turn 90 degrees, you're facing right angles to where you're facing initially, turn another 90, it's 180, turn another 90, then another 90, and you're at 360 degrees. Now, where we have two lines, so for example, if I have a line like so, so this line here, you can look at it as an angle. It's 180 degrees. So imagine it's like two of these, or two of these bits here. So it's 90 and 90. So it's 180 degrees. And this is what's known as a straight line. A straight line angle. If we have something like this then as well. So imagine we have a line like so, and then we have another line passing through it like so, and it's forming a right angle. So these two lines here, so this line and this line, are what's called perpendicular. So they're perpendicular. They're perpendicular lines. So these guys here, so these two lines are perpendicular, and these two lines here are also perpendicular to each other. So they're perpendicular and they form a right angle here. And again, remember, this is 90 degrees. So then, just to go kind of over then some of the other types of angles that we can have. So you can have what's known as an acute angle, and this is an angle that's less than 90 degrees. And sometimes you'll see it like this, less than 90 degrees. So this here is the less than sign, and it looks something like that. So for example, an angle of 46 degrees, that would be considered an acute angle. So we talked about this right angle triangle, so it's 90 degrees. So again, if we have an obtuse angle, so again, an obtuse angle is when you stretch the angle out more than 90 degrees. So it's an angle that is greater than 90, so it's bigger than 90 degrees, but it's less than 180, so it's not completely flat. So that's what's known as an obtuse angle. We have what's known, so we kind of talked about this a little bit as well, so a straight angle, or an angle that's exactly 180 degrees, so it looks something like that. We have then what's known as a reflex angle. So if you think of the opposite side of the outside of your elbow, for example, as you bend your arm, it forms what's known as different types of reflex angles. So a reflex angle then is an angle that is greater than 180 degrees but less than 360 degrees. So let's say, so once you go past, let's say, this 180 degrees, you get these what are known as reflex angles that are formed. So if you think about the opposite, the other side of an acute angle is also a reflex angle as well. So this is known as a reflex angle. So again, it's anything that's between 180 degrees, an angle that's between 180 degrees and 360 degrees. And then you have what's known as a full angle, or even a circle, an angle that is exactly 360 degrees. So again, this is known as a full angle. So then kind of just to move on, so if you have something like this, so imagine you have something like this. So here you have a number of different angles formed. So imagine you have the angle in here, which is A. You have the angle here, which is B, let's say, and then the angle here, which is angle C. So if you add up these angles, so the angle, so let's say, so A plus B plus C, that's going to be equal to 180 degrees. So again, this is if you add them all up, the sum of each of these angles will add up to 180 degrees, let's say in this case. If you have something like this, let's say, so you have an angle, let me just draw this. So again, what we have here, so again, we just have two different angles. So yes, imagine this is A, and then this is angle B. So what's going to happen here, again, is kind of very similar as well. So A plus B is equal to 180 degrees. So again, the point with this one here is that angles which meet at a point on a straight line add up to 180 degrees. So when you have angles, for example, if these three angles, they meet at a point, which is this point here, when you add them all up, they'll add up to 180 degrees. When they all meet at a point on a straight line. If we take this one here, so we have a pair of angles. So a pair of angles that add together to make 180 degrees are called supplementary angles. So when you have a pair of angles like this, they add up to 180 degrees. They're what are known as supplementary angles. Supplementary angles. So again, just another term here as well. So if we have something like this, so imagine we have a number of angles and they're meeting, instead of meeting on a 180 or a straight line, they're actually meeting inside 360 degree. So let's say, so this is A, imagine this is B, C, and D. So these are, so 1, 2, 3, 4 angles. So in this case, the sum of these angles, so A plus B plus C plus D, they're all going to add up to 360 degrees. Then you can have this kind of arrangement here as well. So what you have is you have two straight lines, and those two straight lines are crossing at a point. So the point is here, and what they will actually form are what are known as vertically opposite angles. So it's called vertically opposite angles. Opposite angles. So vertically opposite angles. So what do we mean by that? So let's say, so we'll have, let's say the angle A here, and its vertical opposite is going to be this angle here, which will also be the angle A. We have an angle, let's say B here, and its vertically opposite is going to be this angle here, B. So what we have here then is, so we have these angles that are vertically opposite, and they're equal to each other. So this angle here is vertically opposite to this angle, so therefore these are going to be equal. So these two angles A and A are equal to each other. This angle and this angle are vertically opposite, and they're going to be equal to each other. If you add them all up, they'll be equal to 360 degrees. So again, just so the angle in this case A is equal to A and B is equal to B. So whatever A is, if it's vertically opposite, it's going to be equal to it. Then we have this kind of setup here. So angles formed when straight lines cross a pair of parallel lines. So what we have, if we look at this line here and this line, they're parallel. So that means that they'll continue on in these directions, and they'll never actually overlap with each other. They'll continue on in parallel to each other. So what happens is when you get a line, a transverse line that crosses these parallel lines, you get different types of angles that are formed. So if we have a look at these, so you have, let's say, the angle, so you have this angle here and this angle here. So we'll call this, let's say, A and this B. So these will be what are called corresponding angles. Corresponding angles. And corresponding angles are actually equal to each other. So in this case, so the angle A is going to be equal to the angle B. And a good way to kind of recognize these like corresponding angles, if you look for an F, so you can see that, you look for an F. So in this case, I'm just kind of drawing it a little bit deformed. So you have an F. So where you get an F, so imagine like, so this is the outline of an F, let's say. So the angle in here and the angle in here, these are, so if you take an F, for example, so this angle and this angle, they would be what is known as corresponding angles, and they're equal to each other. So both of these angles will be equal to each other. So you can find them by looking for the shape F, and that's what you get there. So if you kind of look at it, there's an outline of an F, and they're corresponding angles. If we take the angles, so if we look at, so you have, let's say, this angle here, okay, we'll just call this A, and I'm just doing it in a different color, and this angle here, B. So these are known alternate angles. So alternate angles. And alternate angles are also equal to each other. So in this case, A is going to be equal to B. And you can find these if you look for the shape Z. So think of a Z, for example, and you have an angle here in the Z and you have an angle here in the Z. And these are what are known as alternate angles, and they are actually equal to each other. So that's those two guys. So imagine here it looks like a Z, so this down here and here. So this angle would correspond to there, and this angle would correspond to there. And they are known as alternate angles. So your corresponding angles are these two guys here. You're looking for the F, the two angles in the F. So there's 1 and 2. So this one corresponds to here, this one corresponds to here, and then you have this one, which relates to the Z. And then we have what are known as interior angles. So imagine if so this angle A and this angle here B, see the way that they're on the inside of the parallel lines. So they are what are known as interior angles. So again, we'll just write it. So interior angles. So in this case we have so the angle A, which is in red, which is this one here, and then we have the angle B. A is equal to B. So they are sorry, should I actually wrote that there. So with interior angles, what you have is, so let's say the angle A in red, A plus the angle B is in this black color. When you add these up, interior angles, they add up to 180 degrees. So let's say you have these two interior angles. When you add both of them up, this angle here and this angle here, when you add these up, both of them will equal 180 degrees. They might not necessarily be equal to each other, but when you add them up, they'll be equal to 180 degrees. So they're known as interior angles, and they're on the inside, hence why they're known as interior angles. Okay, so that's really, again, it's just a quick kind of revision of some of the properties of angles that you would have covered, let's say, in junior cert. So it's just important to kind of go back and just refresh these, and you can have a look at them. What I'll look at in the next video will be some triangles and their properties as well, because they're going to be important in relation to this topic that we're covering, Geometry 1. And we'll have a look at those in the next lesson. Okay, thank you for listening.